All right, so blip over to codingbat.com, codingbat.com, codingbat.com. We need to make an account, so do create account. Please enter the information to create a new account. You may as well use your school email address. Give it a password, whatever you like. And it's just telling me that the password's already in use. But it should let you in. I don't even think that they send you a registration mail, right? I think I could just make something up. All right. Now we could set it up so that you were hooked up to my account and I could come and see your progress on it, but I just trust y'all to take a screenshot of showing me which ones you've gotten done. And we're not going to set it up that way. So warm up. I'm going to click on warm up 1. There are help files down here if you need some help, like an introduction to strings, how to use substring. I'm not seeing the video that they're referring to, but at least there's some information about how to use substring and so on. Well, let's go ahead and take a look here. All right, the way this works is we're going to write some code that solves the problem that they want us to solve. This one's called SleepIn. We're going to write a function that accepts 2 parameters. One of them called weekday and another called vacation. And the website is going to call our function, our method, and it's going to pass in either true or false for whether it's a weekday and true or false if we're on vacation. Now I want to set this up in NetBeans first, just so that we understand the framework within which we're going to be working. So I'm going to go ahead and load NetBeans. I don't necessarily care if you do or not, because we're just going to wind up typing the same code into here. All right. We're on lecture I, maybe? All right. Choose Ant if you have the choice. Just otherwise choose Java. Project name lecture I. I'm going to remove the project. Excuse me, the package. Click Finish. All right. So I'm going to go back to my code over here and take a look at what they had called the function SleepIn. Now I'm going to have to make a change to make it work inside NetBeans. I'm just going to have to make it static, but we can remember that. Okay, so public boolean SleepIn weekday vacation. Alrighty. So we're going to add a method. What is that? Oh, that's Visual Studio. So public static boolean SleepIn, and it's going to take 2 parameters. Boolean weekday and then Boolean vacation. I'm going to swap my keyboard out with one of the other ones. These repeating keys are annoying. Okay. And then down here in main, I'm going to call SleepIn a couple of different ways. So Boolean A equals SleepIn parentheses true comma true in parentheses. Boolean B equals SleepIn true, comma, false, in parentheses. If you have two states, this is like 2 bits. How many different choices do you have if you have 2 bits? When I finish writing out all these tests, how many am I going to have? I've already got 2, but I want to continue my tests. So I'm going to be setting the first one equal to false. So that it's going to be 4 total. Just like 2 bits gives you 4 total different choices. Boolean C equals SleepIn, parentheses, false, comma, true, in parentheses, semicolon. Boolean D equals, and we're not going to do this for all the problems, we're just going to do this this one time for this one, and then we'll do the rest of them on the website itself. Boolean D equals SleepIn, false, comma, false. We have tested all 4 possible ways. Okay, now the rules are, we get to sleep in if we are on vacation. We get to sleep in if it is not a weekday. Now there's always way more than one way to write something. You know, whether you do something with multiple if statements or whether you do something with and or, you know, or whatever. Now here's what we're gonna do. I'm gonna write it a couple of different ways. If, parentheses, weekday, in parentheses, if weekday equals false, in parentheses, return true, because we get to sleep in. If it's not a weekday, we return true. How about if it's vacation? We get to sleep in. If, parentheses, vacation equals true, in parentheses, return true, semicolon. Otherwise, if those things aren't true, then nope, sorry Charlie, we gotta go. Gotta wake up early and go get our business done. Now that's one way, that's one solution to the problem. If we copied and pasted this code into CodingBat, it would tell us that this is a correct solution. Unpacking index for central repository. I don't care. Why are you telling me you're doing that? All right. So it's not going to do anything. It doesn't provide any printed output. But we could, right? You know, we could make it, you know, if parentheses A in parentheses system.out.println we sleep in when vacation equals true and weekday equals true. Right. That's the only one I'm going to add, but it shows you that you could use this method to determine whether you're going to print a message out or not. Right. So this first test tests it with weekday set to true and vacation set to true. The second test tests it to see when weekday is equal to true but vacation is false. The third test checks what happens if it's not a weekday, so weekday is set to false, but we are on vacation. And the fourth test is if we're neither on vacation nor is it a weekday. And we could figure out in our heads which one of these are supposed to be true and which ones are false. If it's not a weekday, we get to sleep in late. So since the first argument fills in the first weekday parameter, we know that this one should return a false, and we know that this one should return a false. And we're not going to even test it. I'm just going to take it on faith that that's true. But we could write a test framework, right? We could, you know, get that value. We could test it. We could print it out, something like that. But we're just going to take it on faith. Now, if it's a weekday, but we are on vacation, we also get to sleep in. Wait, both of these were supposed to be, yeah. So we get to sleep in. I think I've got these wrong. What's supposed to happen if we test to see, but it's not a weekday, if it's a weekend? What are we supposed to return? We're checking to see if we can sleep in, and we're allowed to sleep in if weekday is not equal to true. So what should the function return? What should the method return if weekday is set to false? Yeah, so my comments were wrong. We also get to sleep in when we're on vacation. So if that variable is set to true, we need to return true. Otherwise, we're going to return false. And we could test all 4 return values and make sure it works, but I'm not going to bother doing that. I'm just going to print one of them out just to show that it works. And hopefully it does. So I ran it, and yes, we do get to sleep in when vacation is true and weekday is true. So even though it's a weekday, since it's a vacation, we got. So what does this coding bat site do? We write this function, and then it tests it. It does this part, and it passes in some various values, and it inspects the results and determines whether we wrote our function correctly or not. Now that's one way to write this code, but there are other ways. We could just use an OR statement or an AND statement, something like that. When we go back to codingbat.com, let's try solving it in a different fashion. So I'm going to come over here, and if we look at our code here, the only time we return false is in one case. Every other case, we return true. So we could write some kind of specialized if statement that would return false in one condition, else return true. Maybe we'll figure out how to do that. So I'm going to come over here, and we get to return true if we are on vacation and if it is not a weekday. So if parentheses vacation equals true, and weekday equals false. No, it's or, right? Because either one is enough to get us to sleep in if we are on vacation or it's a weekend. So change that and to an or. So if vacation is equal to true or the weekday is equal to false, return true. Else return false. That is another possible solution, and there are more. There are other ways you could write it. The way we wrote it in NetBeans is valid. This is also valid. Now I'm talking a lot, right? I don't actually know that it's valid because I haven't hit the go button yet. Let's find out. Contains problems. Semicolon expected on line 5. Oh. What do you know? Right there. Forgot my semicolon. All right. And it worked for all possible cases. False, false, true, false, false, true, and true, true. And just like we predicted, there's only one case where we get a false. The rest of them are all true. Now we could write this more succinctly. What do I mean by that? This statement could be written like this. I'm just going to put it in as a comment. If parentheses vacation or not weekday. That's kind of a short form. If you're checking something against true, you don't have to put equals true. If you're checking something as false, you just put not and then that variable. Return true, else return false, right? That would work just as well. Here's probably the shortest form. Return, still going to comment this one out. Return parentheses vacation or not weekday in parentheses semicolon. That's another way of doing it in a single line of code rather than the 4 lines of code we have here. Why does that work? Because it performs this calculation. That calculation is true or false, and then immediately returns it. So if I commented this code out and uncommented one of these other two lines, it should work just as well. Or if I had done it this way, right? That works as well. Whatever makes the most sense to you, right? In programming, there's rarely only one correct solution. What solution do they offer if we go and look at the hints? Show solution. Like that. Very similar to one of the solutions that I came up with. So solution notes, it's better to write vacation rather than vacation equals true, although they mean exactly the same thing. Also, not weekday is better than weekday equals false. All right, makes sense, gang? Anybody having typos that they need help with? We all good? Okay, let's go to the next one. So I'm just going to click next. And we have two monkeys and two parameters. A, smile if monkey A is smiling, and B, smiling. B, smile if B is smiling. Now we're in big trouble if they're both smiling because they're up to no good. We're also in big trouble if neither one of them is smiling because that means they're both unhappy. And so we need to return true if we are in trouble. So there's, again, more than one way of writing this. I'm just going to pause the recorder and wander around a little bit and see if you can come up with a way of doing this, and if you can't, that's okay. You're just going to have some if statements to handle this business. See, I want to play as well, and it looks like y'all all did about the same solution, which is cool. And there's always more than one way, and if we click show solution, we'd see them all. But we're in trouble if they're both true, and we're in trouble if they're both false. So we could write it like this. If A, smile. Remember we said that we can leave off the words equals true. We could just say if A, smile, and B, smile equals true. And I'm going to delete those equals true. Then return true. How about if they're false? If I'm going to go ahead and delete those equals true business because it's redundant to say that. So if A, smile, and B, smile, return true. If not A, smile, and not B, smile, which is the same thing as if saying if A, smile equals false and B, smile equals false. So if not A, smile, and not B, smile, return true. Otherwise, return false. Now Lindy put an else in there, and that's totally cool. You know, you could put an else there, and you can put an else here if you wanted to. Not strictly necessary either way. Whatever makes more sense to you. That should work. That should work. Or you get a typo. Incompatible type. Missing a return on line 5. Oh, yeah, right. I need something there. Return true. And it tested it all 4 ways. What if I'd gotten it wrong? Right? What if I used an or here? What would it look like when I got it wrong, when I tested it? Now that's not correct, so don't make that change. But see, I'd have to look at these runs and try to debug what's wrong. That it works well for these conditions, but not under those conditions. So it's kind of a thought problem. You'd have to go and figure out why it's not working. All right, there's a short form for doing this. It's just one of those things that if you happen to notice it, you can shorten it, which is if A, smile is equal to B, smile, we return true, right? Because if those are the same or those are the same, then return true. So a short form would be to do this. If A, smile equals B, smile, return true, else return false. And then you could do that in a single line of code if you wanted to, if you like being as terse as possible. Return, parentheses, A smile equals B smile. Like that. That would work as well. So are y'all comfortable at this level? We haven't written a lot of methods yet, but I think y'all are comfortable at this, right? Because you've taken other programming languages or you've learned some Java before, so I think you're good with this. Good, because I'm going to give y'all more of these. All right. So let's find about 3 more for y'all to do at home. Don't do them during the lecture. All right, one called diff21. Given an integer, return the absolute difference between n and 20. No, I'm going to skip that one. I don't want to do that one. Parrot trouble. We have a loud talking parrot. The hour parameter is the current hour in the range of 0 to 23. We are in trouble if the parrot is talking and the hour is below 7 or after 20. Return true if we are in trouble. So for example, if the parrot's talking and it's 6 o'clock, it's before 7, so we're in trouble. If the parrot is talking and it's 7 o'clock, well, it's not less than 7, it's not greater than 20, so even though the parrot's talking, we're okay. And if the parrot's not talking, we're never in trouble. So parrot trouble false, comma 6 would be false. So you can do that one. I'd like for y'all to do that one. Parrot trouble problem. And then here's another one. Given 2 numbers, A and B, return true if one of them is 10 or if their sum is 10. Right? So that might look like if A equals 10 or B equals 10, return true. If A plus B equals 10, return true. Otherwise, return false. Yeah. So those are going to be the 3 that I ask y'all to do at home. Parrot trouble, makes 10, and near 100. And don't do them now. I know you could, but just take a screenshot showing that you did that. Alrighty, screen shut. No, my screen is not shut. Upload a screenshot. What do I mean upload a screenshot? You don't have to take a picture of each page. Just go back to the main page, wherever that was. I guess I just click on Java warm-up, and you know, each one that we solved correctly has a green arrow next to it. I thought I solved monkey trouble, so why do I not have a green arrow there? Oh, because I made a change to it and broke it. So I need to run it and get the test to work again. I had changed and to or. Need to change that back. Now we're good to go. So when I go back to the main page, click on warm up 1, I'll see 2. So I'd like for you to do parrot trouble makes 10 and near 100. If you feel like doing more, that's cool. We'll probably come back and do some others that have to do with strings, right? It starts with something, you know, things like that. Okay, something else we're going to look at is we talked a lot about binary, and I didn't give y'all any homework to do on it. So I'm going to give y'all a homework assignment, but we'll probably just do it in class. So this is homework 7. No, it's not the one that I wanted. I didn't want. Hope it's here. That's the one. All right. If you go to your modules, I guess I could create a folder for it as well. Go to your modules, look in the homework folder, you'll see one called Binary and Hex Worksheet. Or if you can't find it, go to Assignments, find Homework 7, click on it, and you'll get the document. It's a DOC file, so download it. Alrighty. A little typo there. Yo, fill in the yellow blanks on the next 2 pages. Pretend that yo isn't there. Feel free to correct it. Enable editing. Alrighty. So, binary to decimal. We know how this works. Binary is powers of 2. 1, 2, 4, 8, and 16. So if we had this number, 11010, that means that it's a 16, because there's a 1 there, plus an 8, because there's a 1 there. There's no 4s, but there is a 2, so plus 2, and then we just add those up. So, problem 1, following example 1, fill in the yellow blanks. All right, so this is 10101. So what numbers are being added together? Left to right or right to left? Somebody tell me. I'll call names out at random if nobody asks. What are we adding here, Shannon? How many 16s do we have? Yep, we have 16.
4
plus 4
1.
plus 1, so that's a 21. All right. So, take a moment and do those 4, please. All righty. A binary to hex worksheet. I think we talked about this, right? If you have hexadecimal values, each hexadecimal value, which is a digit between 0 through 9 and then A through F, is a representation of 4 bits. We talked about that, right? Feel free to say no. I'm seeing one nodding head, yes. So, if we're going to convert these hexadecimal values to binary, we would just look them up. That's the easiest way. What is a D, by the way? If an A is a 10, 10 is an A, 11 is a B, 12 is a C, 13 is a D. So we could figure out what binary digits added up to 13, but we could also just look up on the lookup table. A D is a 1101, and an E is a 1110. And an A is a 1010, and another D, and then a 7, and a 0, and a 1 and a 1. Okay, so go ahead and fill in these yellow ones the same way. Just scroll up and look on your little fill-in table, your little lookup table. All right, and then vice versa. Converting from the binary to the blanks. So 1111, if we looked up at our list, is an F. 1010, excuse me, 1001, if we looked up, 1001 is a 9. 0110 is a 6. And 1011 is a B. So go ahead and do the yellow ones the same way that example 3 is shown. Alrighty, so hexadecimal, base 16. The letters A through F represent the decimal numbers greater than 9. And so it is based not on powers of 2, like binary, or powers of 10, like decimal, but powers of 16. So the first column is 16 to the power of 0, which is a 1. The next one is 16 to the power of 1, which is 16. 16 to the power of 2 is 256. And 16 to the power of 3, which is 496. So if we have this number, 1, 2, AF, well, a 1 is just a 1. So that's 1 times 496. And a 2 is just a 2. So that's 2 times 256. And then an A, well, we look it up, and an A is a 10. So plus 10 times 16. And then an F is a 15. So it's 15 times 1. And then if we felt like it, we could add them all up and get a result. So I'd like for you to do the same with this one here. Just multiply that times that plus, come on, stop popping up a little help, plus that times that, plus that times that, plus that times that. Alrighty, we're getting close to the end. ASCII. Using an ASCII chart, such as the one at ASCIItable.com, convert the following characters to their decimal ASCII values and their hex ASCII values. So the first one's done for us. Hello, question mark, /n. So we would need to go to ASCIItable.com or another chart. ASCIItable.com. And since I wanted to convert hello, question mark, I'd look up what a capital H is, which in decimal is a 72, and in hex is a 48. And then I would do the same for E. And E is a 69 in base 10, and it's a 45 in hex. And the same for L. L is a 76, right? The question mark, where's the question mark? Well, it's over here in the values less than A. Some of the punctuation is lower in the alphabet, some of it's upper after it, but there's a question mark in here somewhere, I think. Should be a 63, I'm just missing it. There it is, 63. And a space, if we search long enough, we'll spot that a space is a 32. And then that \n, I give it to you to make it easy to find. It's over here. New line. So it's a 10 or an A. So doing the same thing, I'll just bring this up on screen. Not that you can read it, but I'll pause it, put this on the screen. Or you go to ASCIItable.com yourself and do it. Alright, so yes, you can go to HexEdit to check the resulting text, and it was just pointed out to me that HexEdit is taking the enter key to be D rather than A, 14 rather than 10. We could try to find out which one's right. So we're going to go to HexEdit, Control-T, hexed.it, and if I went over there and I typed in, was it good dog? Good dog exclamation mark, hit the enter key, doing a 0D there. I'm going to use Notepad to make the document, have the same text in it. Good dog exclamation mark, hit enter, save as, call it good dog, txt, and now I'm going to use the upload file feature, choose that, and see it treated it as 0A, which is what I had on my worksheet. So I wouldn't count you wrong either way if I asked a question about it. Okay, so using HexEdit, go to hexed.it and enter these hex values and show the resulting text. So you're just going to have to type in 48, 65, 78, and so on. I can't really get them all on the same line. Guess I can if I shrink that. I hit enter. Yeah. So a 48, a 65, and a 78, and so on. Just finish it off. And then go ahead and put them up here. So far it's H and E and X. So I would type H there, E there, X there. So when you got it all filled in, go ahead and upload it into the Dropbox. Excuse me. Okay, so primitive versus reference variables. All of our data so far has been either strings or they've been numeric types, like ints and longs and floats and doubles and chars. Those are all numeric types. You wouldn't think that a character is a numeric type, but just as we've noticed from HexEdit and ASCII-table.com, a character is just a number. So primitive variables hold only one piece of data, and they're declared with a primitive type, which includes int, long, int, long, float, double character. And then there are reference types. A reference type is a fancy word for class, or vice versa. Anything that begins with an uppercase letter in this language is a class and not a primitive type. And so a string, for example, it's a series of characters. It can't just be stored as a number. So they wrote a class to contain strings. And there are other classes. Calendar is a class. There's a whole bunch of different classes. There's thousands upon thousands, and you can make your own. So if you create a variable of a reference type, it basically is a memory address pointing to something that is been created with the new keyword. Let me show you what I mean. Let's go ahead and create a scanner. Scanner SC equals new scanner parentheses system.in. We've done this a lot. And now I need to add the pound sign and the import for it. Not pound sign included, that's C++. Add the import. And there we go. Right? So this declares the reference variable. And we don't give it a value like 12 or 13 or instead we use the new keyword and we create an object, and the object is of this type. It's a scanner. And so we can go and find out what the scanner class does. We could just highlight it and right click and say show Java doc, and it would give us all sorts of information about the scanner class. Once you have a reference declared, this is just a variable that contains the memory address of that object, then you can type in that variable name and hit dot, and it'll bring up a list of all the instance members and methods. So like has next, or next big integer. You know, we've already used like next int and next double in order to pull data out so that the user could type stuff in. So these are all instance members, meaning that once you have an instance of that class, you can access those individual pieces of them. Like you could call .next int. You'd want to create a variable to hold the results, right? But, you know, int age equals sc.next int. So a reference type is a complex data type of type class, right? This is a class right here. A reference variable is essentially just an address, like your home has an address. You live in 123 South Main. Well, this builds your house, makes you a new house, and then it returns the address 123 South Main to be stored in a variable. You could create a second reference variable to hold the same data. Scanner SC2 equals SC. That's just like having two pieces of paper with your home address on it, right? You have one piece of paper with 123 South Main written on it. You go and photocopy it. Now you have two pieces of paper. You don't have two objects. You still only have one house. You still only have one object. You just have two references, right? They both contain the same address. So it's still only one object. It's just that this is a reference to the same object that this one is pointing to. Hope that kind of makes sense, and we'll talk a lot more about that as we go along. So reference variables are more complex. String is a class type. Calendar is a class type. Scanner is a class type. Now string is a special kind. If we did this, string name equals new string with a capital S, parentheses, quote, Becky, end quote, in parentheses, semicolon, that would look familiar based on that. But they made the string class special, and you don't have to use the new keyword to make a new string, right? You can just do string, you know, color equals, quote, red, end quote, in parentheses, and it does that bit for you. But all other reference types, for you to use them, are going to have the new keyword after them in order to create the object whose address it is holding. It's even giving me a warning here saying that string constructor invocation. Meaning that it wants us to get rid of that syntax. It doesn't want us to say new string. I'm going to leave it. Don't need to do it this way. But that's because the developers of Java made strings a special thing so that you can get away with using this shorthand syntax rather than do it like this, which is nice, right? I'd rather type in just string color equals red than new string parentheses quote red. So strings are a class, and they have methods involved, like char@. System.out.println parentheses name dot char for character, char capital A-T. Am I getting that wrong? Let me type in just the dot and pull the whole thing up. Yep, capital A-T, char@, capital A, lowercase t, parentheses, 0, in parentheses, semicolon. And that's going to print out a B, because the first character, the character at position 0, is a B. Now if I copy and replace that, and change the 0 to a 1 and a 2 and a 3 and so on, we'll get the rest of the letters in that name. All right, 1, 2, 3, 4. How many letters is in that name anyways? Let's find out. Let's print out Becky.length. So this is a method. It's a function that's attached to that variable. Well, so is .length. So system.out.println parentheses name dot length, and notice it wants me to tack on parentheses around it because it is a method and it returns an int, so it's going to be a number. It's just a number of characters in it, which since Becky has got 5 characters long, if you spell it with a Y, that's going to be the last thing we see when we print it out. And so it printed out, right? That's character 0, that's character 1, that's character 2, that's character 3, that's character 4. And so since the string is 5 letters long, 5 characters long, we can access elements 0 through 4. The indexing starts at 0 rather than 1. If we were computers, when we learned to count as babies, we'd start counting at 0. All right, use all your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Now we've used up 10 fingers, because there are 10 digits. 0 through 9 are all 10 digits. If the minimum is 0, then the max is length minus 1, right? So since the length of the name is 5 characters long, there's 5 letters in it, then the highest you can get is 4. What happens if you increase that to 5? We're not going to like the results. Boom. String index out of range. So since it is 5 long, we can only access elements 0 through 4. If we access anything larger than 4, it's out of range, and so we're going to get that exception. So string methods include .char@, .length, and there are others. There are plenty others. Type in name dot, and we'll get a list of a whole bunch of methods. Index of, is empty, notify, a whole bunch of them. Now we're going to use a couple more of them. What if we want to check to see if these two strings are equal? They're not, but what if we thought they might be? If, here's how you do it in Python, and it's not going to work. Name equals color. Doesn't work in this language. Instead, you have to use the .equals method. If name .equals parentheses color, in parentheses, system.out.println name equals color. Now I can't think of too many first names that are equal to colors. Maybe Violet, not a very common name anymore. Amber, Amber is. So why don't we change our name equal to Amber and our color equal to Amber? I assume everybody knows amber is basically yellow. And then when we run it, this is going to compare those two things, and it is going to print that the name equals the color. But we should have an else here to tell us that they don't equal. Else system.out.println name does not equal color, end quote, in parentheses, semicolon. So now we've learned 3 methods: .char@, .length, and .equals. All right. And name does in fact equal color because we set them the same. But what if we made them different? Right? What if we made our color red? They no longer match. Now, what would have happened if we had used the double equal sign? It might have worked, it might not have. Don't make this change. I'm going to demonstrate for you that it's wrong. If name is equal to color, and I'm going to fill this in, amber, and I'm going to leave that like that, and I'm going to see if it prints that the name is equal to the color. What do you know? Name does not equal color. Well, yes they do. Yeah, but these are 2 different objects. And if you use equal, it's comparing the addresses. So just because there's a house next door to me that looks exactly the same as my house, they're not sharing the same address, right? I have my own address. This is just checking the addresses of the objects. One string was created at one address in memory, the other string was created at another address in memory. So even though those two addresses have the same contents, just like two houses on the street that are painted the same, they don't share the same address, and that's all that's checking. So can't do it that way. I'm going to undo that, and I'm going to put a comment here. Don't compare strings with equal equal. Instead, use dot equals. And it's about time to end. So don't do if parentheses name equals color. Instead, use if parentheses name dot equals parentheses color in parentheses in parentheses. That's the only way to compare strings. It may occasionally work right if you do it the other way. More often than not, it's not going to. All right, we've already got our homework assignment since I gave y'all some coding bat problems, so we're not going to create another one. I'll write up that part of the assignment and create the folder for it. You're just going to do some of the coding bat problems and upload a screenshot. That makes sense, gang? Mm-hmm. All right, let's make a Dropbox and be done.